Hi, in this particular video we're going to be looking at a very specific part of the kind of questions you're going to get. This is about Pythagoras and SohCahToa type questions combined. So it's the questions where you've got a little bit of Pythagoras, a little bit of SohCahToa. They do come up actually quite a lot in GCSE, so please do stop the video, have a go at each of the questions, compare your solutions. If you've got any particular questions, always add a comment. I'll come back to you. I look forward to seeing you inside the video.
Okay, so in this particular video we're going to be looking at combined Pythagoras and SohCahToa questions. They are fairly straightforward, but you do need to be able to separate the two from each other. So when we're looking at, say, question 1, in order for us to find out the value of x, we need to know the value of this particular line across here, which is actually the hypotenuse of triangle A. So what I'm going to do is I'm firstly going to look at triangle A on its own, and I'm going to use Pythagoras as a squared equals b squared plus c squared. Now you might use c squared equals a squared plus b squared. That's perfectly fine, doesn't really matter. What we're basically saying is the square of the hypotenuse, which is the long line that we're looking at, is equal to the sum of the squares of the other two sides. So in other words, it's going to be 8.4 squared plus 15.6 squared, and when we put that into our calculator we're going to get 313.92. So basically the value of A is going to be the square root. Now if you're not sure about anything that I'm talking about here, please do let me know in the comments and I'll direct you towards a Pythagoras specific playlist. But on this particular one, what we're saying is this value of the line is going to be basically the root of 313.92. Now I could write it out if I wanted to, but it's actually a very long 17.71778 767 and so on. So it's not really worth too much time. I might as well just write it as a square root. And then effectively I can then look at triangle B, which is going to be this triangle here, and use the information I've got, because effectively the line that we've just worked out is the opposite to x. Okay, so what I can say is that if I use the ratio SohCahToa, I can then look at triangle B and say actually this line is the opposite, the longest line is the hypotenuse, and the one that's left is the adjacent. And again, if you're not sure about anything, please do let me know and I'll direct you to a playlist on SohCahToa. Okay, so the ratio I'm going to use is going to be the sine ratio, because I know the opposite, I've just worked it out. I know the hypotenuse is 19.5, so therefore I can say the sine of x equals the opposite over the hypotenuse, which is going to equal to the root of 313.92 all divided by the hypotenuse of 19.5. Now that's going to give me the sine. The sine I'm not interested in. What I'm interested in is the actual value of the angle. So therefore if I use shift sine on my calculator, I can access the inverse trig function, which is sine to the power of -1, and I would write that as the fraction 313.92 all divided by 19.5, and when I put that into my calculator I'm going to get 65.3132. and if I go back to the actual question, it asks me to give the answer to 3 significant figures, which is going to be 65.3 degrees, and that will be 3 significant figures, which is the answer to question number 1. Okay, so that's the general principle. So as we're working through this, it might take I might take a few shortcuts, but hopefully we'll be okay with it. Let's have a look at question number 2. Please do stop the video, have a go at this particular question. Okay, so on to question number 2, where effectively I'm looking at triangle A. Now triangle A, I can use Pythagoras, which is a squared equals b squared plus c squared, and that will help me work out this missing side of triangle A. So what I can say is that the hypotenuse is A, so that's going to be 13 squared equals B, which is the bit I'm looking for, plus C, which is 12 squared. So therefore, if I want to work out B squared, it's going to equal 13 squared minus 12 squared. Well, that's going to give me 25 equals B squared, so therefore B must equal 5. So therefore this triangle here has a side length of 5. Okay, so then I look at triangle B, and with triangle B I can then use SohCahToa. So let's look at B, and I'm going to look at SohCahToa. And what we're being asked to do is work out the length x. Okay, so let's label it first. Well, firstly, opposite 38 is actually going to be this side here, which is the opposite, okay, which is a side length of 5 that we just found out. The adjacent, the hypotenuse is the longest side, and then the adjacent is the side that we're actually looking for. So therefore, if I look at my SohCahToa ratio, it's actually the tangent ratio that I'm interested in, because I know the opposite, I'm looking for the adjacent, and I know the value of the angle, which is 38. Therefore, I can work out the tan value. So I have tan of 38 degrees equals the opposite divided by the adjacent. Okay, so that's therefore going to be the adjacent, tan 38 degrees equals the opposite, which is going to be 5, divided by the adjacent. Now there's a little bit of algebra that needs to go on here. Now again, if you're not sure about any of these things, please do let me know in the comments, but effectively I need to make the adjacent the subject of this particular equation. So therefore I can write it as adjacent equals 5 divided by the tan of 38, and there is a process which you can go through to actually work that out, but it's going to, when I put this into a calculator, it's going to give me 6.3997 centimeters, and again to one decimal place that means my value of x is going to be 6.4 centimeters, which would be the answer to this particular question. So I do understand that I am skipping a few things here. These questions are a little bit more challenging, but if you have seen the other videos on SohCahToa and also Pythagoras, then hopefully that should help you. Okay, so let's move on then to question number 3. So question number 3, again, 2 right angle triangles. So the first thing I'm going to do is I'm going to mark this as triangle A, which is the first left hand side, and I'm going to mark that I need to find out the value of actually the adjacent is going to be this one over here. Okay, now opposite 32 is going to be this line here. The hypotenuse is going to be 19, and the line I'm looking for is actually going to be, in this particular case, the adjacent. So I can mark that out as the adjacent here. So all I'm doing is just concentrating on triangle A. So again, I'm going to write out my ratios. SohCahToa. Okay, and the one I'm going to choose in this particular case is the cosine. Now the reason I'm going to do that is because I'm looking for the adjacent. I know the hypotenuse is 19. I also know the angle is 32 degrees, so therefore I can work out the cosine of it. So I could write cosine of 32 degrees equals the adjacent, and remember that's the one I'm looking for, divided by the hypotenuse of 19. So therefore, if I want to work out the adjacent, I'm going to multiply the cos of 32 by 19, and I'm going to get the adjacent. Adjacent is going to equal to 16.1129, and that would be meters. Okay, so therefore I can now look at triangle number B. And what I've got for B is effectively the hypotenuse, which is x, because it's the longest side. I've worked out the adjacent, or if you like, side B, and I also know that side C is going to be 9.8. So therefore I can just write for triangle B that a squared equals b squared plus c squared, okay, and therefore B, now rather than writing in 16.1129 squared, I could actually just use my calculator. I can use answer squared. Now, it's not always a good trick. You might want to just type in 16.1129, but in this particular case on my calculator I haven't changed anything, so therefore I can just use the answer as it is rather than writing in all the digits. And then c squared is going to be 9.8 squared. When I put that into my calculator, I'm going to get the horrendously long number. That's the problem with some of these types of calculations, where you get these very large numbers that you have to deal with, of 355.66, so on. Okay, if I square root that, I get the value of x, which is effectively going to be the value of a itself, and that's going to give me 18.8591, and therefore to one decimal place it means that x is going to equal to 18.6, and that's to one decimal place, 18.6 meters, and that would be the answer to question number 3. Okay, hopefully that's okay for you. Please do stop the video, have a go at each of these questions and compare your solutions. So let's have a look at number 4. Well, number 4 is a kite. Okay, well, what a kite tells us is that we basically have two isosceles triangles. Well, that's perfectly fine. So if we look at triangle number A, what I'm going to do is I'm going to draw a line down the middle there, and that means I can use then SohCahToa to be able to work out effectively the opposite, which is this length along here, which is going to be the half the length, if you like, of AC. Okay, so triangle A, I'm going to write my ratio, SohCahToa, and effectively what I've got is, if I just draw just a very quick diagram for you, I've got a right angle here. I know this is 39 degrees because it's half 78. I know this is 18 because it tells me in the actual drawing there, and therefore I know that the bit I'm looking for is the opposite. This would be the hypotenuse, which is the side length of the kite, and then 18 would be the adjacent. Okay, so therefore I'm going to use the tan ratio. So I'm going to say the tan of 39 degrees equals the opposite, which is what I'm looking for, all divided by the hypotenuse, which is going to be, in this particular case, not the hypotenuse, I beg your pardon, the adjacent, which is going to be 18. Okay, so if I want to work out then the opposite, which is the line I'm looking for, I'm going to multiply tan 39 by 18, and I'm going to get that this is 14.576 1126 equals the opposite. Okay, so that's basically this length over here. Okay, so I can actually now create myself another right angle triangle, and now I can use Pythagoras to be able to work out triangle B. Okay, so let's have a look at that, and again I'll just draw a very quick sketch for you. It's kind of long and thin, like that. It's got a right angle there. Now this is going to be 32 because it tells us that in the actual sketch. This opposite is actually going to be this one here. It's actually the answer of part A. Okay, and then x is the hypotenuse length, which I'm actually looking for. So I can say that a squared equals b squared plus c squared. Well, that's going to be equal to, again, I'm going to use answer squared because I haven't changed my calculator. It just saves me writing out 14.5761126 squared, which I'm sure you'd get very bored with me writing that, plus my writing isn't particularly great anyway, plus 32 squared. Okay, Pop that into a calculator, and again I get this horrible 1,236.463058. Okay, having a look at my particular question, it says give the answer to 3 significant figures. Oh, I need to square root it rather. So if I square root it, I get x equals 35.16337, and to 3 significant figures that means the actual answer would be 35.2 centimeters, and that's 3 SF. Okay, so that's my answer to part 4 of this particular question. Okay, so we've got 2 more questions to go on this particular worksheet. I hope it's useful. It should give you lots and lots of experience of dealing with combined Pythagoras and SohCahToa questions. Now this one is a little bit trickier because it's quite a wordy question. There's quite a lot going on here, so I will refer backwards and forwards as I'm going through, but basically the first one it wants us to work out is the height of the ladder DC. Well, that's okay because I can use SohCahToa to do that. Then it wants us to work out the length AD. Well, that's fine, I can use Pythagoras. And then it also wants us to work out the elevation of D from B, which is going to be back to SohCahToa again. Okay, so let's have a look then at the first one, which is to work out the height DC of the actual ladder itself. So effectively this is opposite. Okay, this is the hypotenuse, and therefore this long side over here is the adjacent. So if I want to work out A, which is the answer to the length DC, I'm going to use SohCahToa again. SohCahToa. Okay, and the ratio that I'm going to choose is going to be tangent, because I know the adjacent, which is 35 meters. I know the angle, which is 32 degrees. I'm also looking for the opposite, so therefore I can write that the tan of 32 degrees equals the opposite, which is the bit I'm looking for, divided by 35. So if I multiply both sides of the equation by 35, I'm going to get that 21.8704 equals the opposite. Okay, and to 3 significant figures, it means that DC, which is the bit I'm looking for, is going to be 21.9 meters, and that's to 3 SF, which is the answer to part A. Okay, so hopefully that's been okay for you. Let's move on then to part B. I'm going to try to keep this onto the same screen if I possibly can. Okay, with part B, you'll notice now that effectively I know my opposite, which I've just worked out. I also know then that I've got a right angle triangle, so therefore I can write my opposite in as 21.9 meters. Now, when you're actually using your calculator, as I've mentioned before, you should actually, if you can, use the answer key, because it will be much more accurate. Okay, so rather than using 21.9, I've worked it out to 4 decimal places as 21.8704. Can't quite remember, it might be a little bit more than that on your calculator, but you should try to use the answer key if it's not too difficult and it's not too confusing. Okay, so let's have a look at part B. I'm going to say that A squared equals B squared plus C squared. Okay, well, A is actually going to be the hypotenuse in this particular case, so it's going to be the answer squared plus 35 squared. Put that into a calculator. I'm going to get A squared equals 1703.315591. So therefore A, which is the same as AD, is going to equal 41.3 meters, and that's to 3 SF. Okay, hopefully that's okay for you. Let's have a look then at part C. So again, I'm trying to kind of keep this on the same screen if I can, but part C is asking us for the angle of elevation. So let me just clear what I've written over here. I'm just going to get rid of that answer there. Okay, that's fine for me. So the angle of elevation of D from B is basically this angle over here, which we're going to call X. So again, I've worked out my answer DC, which is my opposite. But this time, the longest line is actually going to be this line, which is BD, which is actually the hypotenuse, and then the one that's left, which is the 16-meter one, is actually the adjacent. So again, I'm going to write my ratio, SohCahToa. Okay, and I'm going to choose the tangent ratio. Now the reason I'm going to choose the tangent is because I'm looking for the opposite. No, I'm not. I'm looking for the angle, but I know the opposite and I know the adjacent. Okay, so I can say that the tan of x equals the opposite over the adjacent, which is going to equal to 21.9, but again I'm going to use my answer key if I can, and also my adjacent is 16. When I put that into the calculator, I'm going to get my actual tangent. I'm not really interested in the tangent, I want the angle itself. So therefore, if I use the shift tan key, I get tan to the -1, it's the inverse reciprocal, and again I would type in answer over 16, put that into a calculator, and this time it will convert to the actual angle itself, and to 3 significant figures that's going to give me 53.8 degrees, and that's to 3 SF as well. Okay, and that would be the answer to part C of question number 5. Okay, I hope that's been useful to you. It is condensed a little bit, but if you're not sure about anything, let me know and I'll always come back to you. Okay, let's move on then to the final question in this particular worksheet, which is a diagram showing again 2 right-angle triangles, and we need to work out the value of x. Okay, well, in order to do that, let's have a look at working out the length AC, because effectively we can use Pythagoras to deal with triangle A. Okay, so triangle A is going to be A squared equals B squared plus C squared. Okay, so I'm going to have 38 squared plus C squared is 35 squared. Put that into a calculator, I'm going to get A squared equals 2669. Square root it means my value of A, which is the same as AC, is going to equal 51.6623. 6541. Okay, and that's absolutely fine. Now what you'll notice is in the question it also says that length AB is exactly the same as length BC. So therefore, if we halve this value, that's going to give us the opposite to 43 degrees. It's actually going to give us this length along here. So this length along here is going to be half the value because it's equidistant. AB is equal to BC. So therefore, let's have a look at how we can work this out. This is going to be my opposite. The longest side is my hypotenuse, and then this is my adjacent. So when I'm dealing with triangle B, I'm going to use the SohCahToa form. So SohCahToa. Okay, the one that I'm particularly interested in is going to be the sine rule. Now the sine rule is because I'm looking for the hypotenuse. I know the opposite because I've just worked it out, and I know my angle is 43 degrees. So therefore I can say that the sine of 43 degrees equals the opposite over the hypotenuse. Okay, well that means then I can write that as saying actually the opposite is half my previous answer, okay, because it's halfway along, divided by the hypotenuse, which is what we're trying to work out. Okay, so let's just make that a little bit easier to read. Okay, so I've got the sine of 43 equals half of the answer divided by the hypotenuse. Now I want to make hypotenuse the subject of this particular formula. So therefore I need to just swap things around a little bit, and again it's a little bit of algebra. If you're not sure about how I've done this, please do let me know in the comments and I will come back to you. But I'm going to write this as hypotenuse equals half the answer of the previous part A, if you like, divided by the sine of 43 degrees. Put that into the calculator and I'm going to get 37.875725. Oh, I'm getting bored now. Okay, it goes on a little bit, but basically it means then to one decimal place that's going to equal 37.9 centimeters, and that's 1 dp for the value of x. Okay, and that's the end of this particular worksheet.
Okay, so I hope the video was useful to you. If you're not sure about anything, always add a comment. I'll come back to you, subscribe to the channel, and I look forward to seeing you inside the next video.